What happened 11,034 meters beneath the ocean's surface that defied every law of physics? And why did scientists find themselves questioning everything they thought they knew about the deep sea? From sudden heat surges to mysterious signals and impossible forms of life, every expedition revealed phenomena the abyss refused to explain. Stay with us, because what researchers discovered at the bottom of the trench will terrify and amaze you. The reading that broke the rules of depth. At 11,034 meters below the surface, numbers are supposed to behave. Pressure reaches levels that crush steel, molecular motion slows, and temperature gradients flatten into near silence. That assumption shattered the moment a deep trench sensor transmitted a heat spike where none should exist. It was not gradual, not diffuse, and not explainable by any known deep ocean process. One clean data point arrived on a researcher's screen and forced an immediate pause across multiple monitoring stations. Early confusion gave way to disbelief as technicians verified the instrument's integrity. The sensor had been calibrated weeks earlier under controlled conditions. Its housing showed no breach. Its power draw was normal, yet the reading persisted, a localized thermal surge pulsing upward from the deepest part of the trench. At that depth, pressure should suppress nearly all thermal variability. Heat does not move freely there, it settles. This reading refused to settle. Cross-checks began immediately. Adjacent instruments were queried, not for temperature, but for pressure fluctuations, salinity anomalies, and electrical noise. None appeared. The water column above remained stable. No tectonic shift had been logged. No volcanic activity was present within hundreds of kilometers. The heat existed alone, detached from every known trigger. That isolation made it more troubling, not less. What unsettled researchers most was the shape of the anomaly. It was not a plume or a smear. The data suggested a contained pocket, almost as if the heat were being held in place against overwhelming pressure. In laboratory physics, that kind of thermal persistence requires structure. In the open ocean, structure at that depth is not supposed to exist. The trench was assumed to be thermally inert, a cold sink at the bottom of the planet. That assumption quietly collapsed. Historical models were pulled from archives and scrutinized line by line. Deep ocean circulation theories predict slow, predictable energy movement over centuries. Nothing in them allows for abrupt thermal events at extreme depth. Even hydrothermal vents, often invoked as a catch-all explanation, operate within known geological boundaries. This signal did not match vent signatures in intensity, chemistry, or duration. It was too clean, too sudden, and too isolated. A deeper unease set in when archived data from earlier missions was re-examined. Researchers found faint, previously dismissed irregularities scattered across decades of trench measurements. At the time, they were written off as sensor drift or background noise. Now they appeared as echoes of the same phenomenon, smaller and easier to ignore. The trench had been whispering for years. No one had been listening closely enough. The implications reached beyond oceanography. Temperature governs chemical reaction rates, material stability, and energy transfer. If the deepest ocean could host spontaneous heat surges, then its role in Earth's energy system had been misunderstood. The trench was not a passive endpoint. It was active, responsive, and capable of behavior that current physics could not comfortably explain. Meetings grew tense as teams debated whether to publish or delay. Releasing the finding meant inviting scrutiny that could not yet be answered. Holding it back meant admitting that something fundamental had slipped past established science. The data did not accuse. It simply existed, indifferent to human discomfort. That indifference made it impossible to ignore. As the first report circulated internally, one realization spread faster than the heat itself. If energy could appear and persist in a zone meant to be silent, then other signals might be hiding there too, waiting to be reclassified. What else had been buried beneath assumptions rather than sediment? And what would happen when scientists started listening instead of just measuring? Stay with us as the mystery deepens. Signals from a zone meant to be silent. The ocean at 11,000 meters is supposed to be quiet. Silence dominates. Sound should barely travel. and if it does, it should be incoherent, chaotic, or faint echoes of distant earthquakes. That expectation shattered when hydrophones positioned near the trench began to detect structured patterns, bursts of energy too precise to be random. They weren't faint blips. They were sequences with rhythm, duration, and repetition that suggested an intelligent or at least consistent source. Researchers initially assumed mechanical interference. Equipment malfunction is common in extreme depth deployments. Every cable, sensor, and data logger was examined. Nothing malfunctioned. There was no background interference, no shipping noise, no seismic anomaly to explain the regularity. The sequences repeated in a pattern that made statisticians pause, blinking at graphs that should have been featureless. Unlike shallow water acoustic signatures, these signals maintained coherence across kilometers. Deep sea sound generally disperses rapidly under crushing pressure and dense cold water. Yet here, the acoustic energy remained remarkably focused. The signal structure suggested channels or conduits invisible to sonar, or a medium behaving differently from known physics. The ocean itself seemed to be carrying sound in ways no textbook had predicted. Attention shifted to frequency analysis. Instead of chaotic, low-frequency rumbles, the signals contained bursts at ultra-low and ultra-high ranges simultaneously. Conventional marine life could not generate such a spectrum, nor could geological events produce consistent duration and spacing. One researcher whispered the term persistent energy source, realizing the deep trench might not only produce heat, but also communicate in its own unique acoustic language. Teams debated possible origins. Some speculated about unknown geological oscillations, minute movements of subducting plates producing the rhythmic pulses. Others considered chemical reactions creating cavitation events. Every hypothesis collided with inconsistencies. No seismic tremor matched the intervals, no chemical gradient could sustain the intensity, and yet the signals persisted, day after day, like a heartbeat in the darkness. The phenomenon forced a rethinking of the trench as a silent void. If energy could organize itself acoustically in total darkness, the trench might host dynamic systems operating entirely outside human comprehension. This revelation cast doubt on long-held assumptions about oceanic dead zones. The abyss was neither passive nor inert. It had behavior, memory, and, perhaps, intention encoded in its vibrations. As the team expanded their investigation, instruments recorded anomalies in unexpected ways. Hydrophone arrays began picking up correlated movements of water masses, subtle shifts in salinity coinciding with the signals, almost as if the medium itself was modulating sound. The trench was not just a backdrop, it was a participant, a system with internal logic that humans were only beginning to glimpse. Each night, as data streamed into laptops aboard the research vessel, analysts became haunted by the possibility that the signals were telling a story not written for human understanding, but revealing a hidden layer of energy and life far removed from the surface world. Something beneath the weight of 11 kilometers of water was moving, thinking, or at least responding in ways we had never imagined. Could the trench's acoustic patterns reveal the mechanisms behind the impossible heat surges? Were these signals a reflection of forces that had gone unnoticed for millennia, silently shaping the abyss? Come with us to explore the hidden corners of the story. The collapse of known biology. Where sound had revealed organized energy, biology revealed outright impossibility. Sensors deployed in the trench captured movements, shapes, and thermal signatures that defied the accepted limits of life. Proteins and enzymes are supposed to denature at extreme pressure. Membranes collapse, metabolic reactions halt. Yet instruments recorded entities moving with coordination, feeding and reacting in ways no textbook could explain. The first indication came from remotely operated cameras. Tiny flashes of iridescence appeared near sediment fissures, too brief and sporadic to be the result of light reflection. Over weeks, these flashes resolved into forms resembling transparent, gelatinous organisms, far larger than models predicted could survive without constant energy input. They did not merely drift, they navigated, maintained shape, and responded to the movement of research vehicles. Chemical sensors added another layer of shock. The organisms emitted unusual organic compounds, polymers not cataloged in any database. Standard amino acids were scarce or absent. Instead, these life forms appeared to rely on exotic biomolecules capable of withstanding crushing pressure and near-freezing temperatures. Their internal chemistry was more alien than terrestrial. Scientists realized the trench was hosting an ecosystem operating under rules that resembled life on another planet rather than Earth. Even movement patterns broke conventions. Species in deep waters normally conserve energy through slow, drifting locomotion. These organisms displayed bursts of activity, seemingly deliberate, sometimes forming clusters or trails. One theory suggested coordinated hunting behavior. Another hypothesized chemical communication that could operate without light. Every explanation required reevaluating the assumed boundary between what is biologically possible and what is not. Further anomalies came from microbial mats covering vent chimneys. Their metabolic rate was far higher than predicted. Stable isotope analysis revealed a source of energy not derived from organic detritus. Instead, these microbes appeared to draw power directly from geophysical processes, pressurization, minute chemical gradients, and perhaps even the mysterious heat spikes documented in Chapter 1. Life in the trench was not scavenging. It was engineered by the environment itself. As researchers deployed more sophisticated instrumentation, entire trophic chains began to emerge. Predatory behavior, symbiotic clustering, and energy recycling were evident at scales previously thought impossible. This ecosystem did not merely survive the trench. It thrived in defiance of physics and chemistry. Deep-sea biology textbooks suddenly looked like fiction. One night, an unshielded light from a lander revealed an outline of something large and sinuous, stretching tens of meters across a valley floor. Movement rippled in synchrony with faint acoustic pulses recorded nearby, hinting that the signals from Chapter 2 might be part of a biological network, rather than purely geophysical phenomena. A new question arose. Had scientists been hearing the heartbeat of a hidden civilization of organisms all along? If life could persist under such extreme alien conditions, then what other mechanisms or strategies had evolution invented that remained invisible to human eyes? And more importantly, how far could such adaptations go without ever touching the surface world? Let us guide you into what no one expected. An ecosystem without a visible power supply. The abyss defied expectation again. Cameras and chemical probes showed life forms moving with purpose and feeding with precision, yet calculations revealed no sufficient source of energy. Organic material drifting down from the surface could never account for the metabolic demands of these large organisms. There was no sun, no substantial photosynthetic input, and no accumulation of food from above. Something entirely different powered this ecosystem. Investigators first suspected chemical gradients, like those near hydrothermal vents, but vents were rare in the survey area, and energy output from known vent systems could not explain the consistent activity. Measurements revealed trace but unusual concentrations of sulfur, methane, and metallic ions, hinting at chemical energy sources beyond conventional understanding. Life in the trench was tapping into processes that Earth scientists had barely begun to quantify. Movement patterns provided another clue. Creatures appeared to remain dormant for extended periods, sometimes weeks or months, only to spring into rapid activity in response to subtle environmental cues. Sensors recorded sudden bursts of heat localized around these events, suggesting energy storage mechanisms far beyond anything seen in surface biology. These organisms were neither lazy nor passive. They were patient engineers of their own survival, storing and deploying energy with precision. Even more astonishing were interactions that implied cooperative strategies. Certain organisms clustered around mineral deposits, while others congregated in zones with unique pressure oscillations. Their behavior suggested a sophisticated understanding of environmental energy flows, how to maximize survival in a world that should have starved them. Energy was being harvested in ways completely hidden from human observation, as if the trench itself were an invisible power plant supplying the ecosystem. One team recorded a sequence that shocked them. A gelatinous predator emerged from a trench crevice, its biochemistry apparently extracting energy from subtle shifts in the water column. Its tentacle-like appendages moved almost mechanically, drawing minute chemical energy directly from sediment layers. No digestion of conventional matter occurred. Life in this ecosystem could thrive without prey in the conventional sense, rewriting assumptions about food webs and survival thresholds. Microbial colonies added another layer of intrigue. These mats consumed chemical energy from fluidized sediments and transformed it into bioavailable forms for larger organisms. The relationship suggested a hidden hierarchy of life, one that functioned without light, without detritus, and without surface nutrients. Each level of the ecosystem relied on mechanisms entirely alien to terrestrial biology, forming a network of energy exchange invisible to ordinary observation. As the team examined these findings, a chilling thought took hold. If life could survive for decades without conventional sustenance, silently harvesting chemical or geophysical energy, then the trench was far more autonomous than previously imagined. It was a self-sustaining biome operating on rules we had yet to comprehend. The implications for biology, energy science, and even planetary exploration were staggering. If organisms could live indefinitely without what humans consider essential energy, what other invisible forces or hidden mechanics might exist in the depths? Could this ecosystem hold secrets that redefine the very limits of life? Come with us into the truth that was never meant to surface. A seafloor that erases evidence. Exploring the abyss, researchers quickly realized that the trench was not just a container for impossible life. It was a shifting, unpredictable landscape that actively concealed its secrets. Instruments that survived crushing pressure often returned data that seemed contradictory. One day, a sediment valley appeared brimming with life. A week later, sonar scans showed only a smooth, featureless plain. Sections of the seafloor seemed to vanish, leaving nothing behind. Initial theories blamed sediment slides, but nothing in known geology matched the suddenness or scale of these changes. Remote-operated vehicles, ROVs, recorded collapses as if the ground itself liquefied for a moment, swallowing entire ecosystems in silence. Camera feeds documented swirls of particulate matter rushing downward, erasing footprints, discarded shells, and fragile microbial structures in minutes. The trench was not static. It was an active participant, constantly reshaping itself in ways that obscured everything living within it. Scientists observed strange chemical bursts coinciding with these collapses. Tiny explosions of hydrogen sulfide and methane occasionally erupted, not in the violent, high-energy way typical of venting, but in controlled pulses that appeared to soften and refluidize the surrounding sediment. These chemical events seemed perfectly timed with the movements of the organisms, almost as if the ecosystem anticipated and adapted to the changes. Observing the trench felt like stepping into a living, breathing entity rather than a static environment. ROVs recorded subtle traces that suggested previous inhabitants had existed where the seafloor now appeared empty. Bent sensors, crushed equipment, and faint trails of movement indicated that creatures larger than any documented species had once traversed the region. Yet all physical evidence of their presence vanished quickly. Even advanced sonar mapping failed to detect lingering structures. It became apparent that the trench was not merely erasing human-made instruments, it was erasing life itself, leaving behind an illusion of emptiness. Teams attempted to use time-lapse cameras to track seafloor changes. One experiment captured an entire microbial mat colonizing a fissure overnight, only for the mat to disappear by the next morning. Chemical tracers injected into sediment layers were carried away or neutralized almost immediately. The trench was actively metabolizing and redistributing material on timescales that defied understanding, creating an environment where even carefully monitored experiments failed to hold. Geological models could not account for the speed or precision of these transformations. Sections of trench floor shifted without detectable seismic activity. Fine sediments would liquefy and collapse as if obeying unseen forces. Some researchers speculated about extreme pressure differentials or fluidized earth layers moving through porous channels, but nothing fully explained the simultaneous disappearance of biological and instrumental traces. It was as though the seafloor had a memory and a will to conceal what lived there. The implications for research were profound. Every discovery risked being erased before it could be documented. Scientists realized that the trench was not merely hiding its secrets by depth or darkness, it actively participated in erasing them. This environmental self-censorship meant that sightings of life, chemical anomalies, or even physical structures could exist only for brief moments before being obliterated. The abyss was simultaneously a habitat, a laboratory, and a vault of vanishing evidence. The trench's behavior also suggested a connection to the mysterious organisms discovered earlier. Could these creatures, capable of surviving without conventional energy, somehow manipulate the seafloor or influence sediment flows? Certain patterns hinted at non-random coordination between life and landscape. Collapses often occurred near clusters of living organisms, and unusual chemical pulses appeared in precise intervals coinciding with biological activity. It was impossible to determine whether the seafloor dictated life's behavior or vice versa. One particularly chilling discovery occurred when a camera captured a series of undulating tracks across freshly deposited sediment. They appeared to be made by a large organism moving along the ridge, yet by the time the footage was analyzed hours later, the tracks had vanished, the sediment leveled as though untouched. Scientists were forced to confront the unnerving reality that what they observed in the trench was not permanent. The environment itself was an active agent, erasing traces and masking interactions, leaving only glimpses of its secrets. As researchers tried to adapt, new techniques were developed to record fleeting moments: ultra-fast chemical samplers, high-speed cameras, and arrays of microhydrophones. Still, every tool faced the same obstacle. The trench refused to be fully understood. Its shifting floors, chemical eruptions, and erasure of evidence suggested a depth of complexity far beyond known ecological or geological systems. It was an ecosystem that hid not just its inhabitants, but the very story of their existence. The realization was unavoidable. The abyss did not allow humans to be passive observers. It demanded interaction, adaptation, and a recognition that nothing recorded there would remain untouched for long. Each new discovery was temporary, a fleeting flash in an environment determined to erase memory. And if the trench could erase evidence of what existed, what might it do when humans themselves attempted to interact more directly? Could the seafloor's erasing nature be the key to understanding why previous missions failed to capture these organisms or the anomalies around them? Stay with us as the secrets grow even darker. When observation became interaction. The abyss, once a silent backdrop for instruments and cameras, began to demand more than passive study. ROVs sent into the trench started returning footage that was impossible to ignore. Objects shifted in ways that suggested they were not simply being moved by sediment flows. Cables became entangled in patterns that implied deliberate interference. Mechanical arms touched surfaces only to find them altered the next time the same spot was revisited. Observation had become interaction. One lander, designed to remain stationary for weeks, began transmitting erratic data. Its manipulator arms recorded resistance as if something unseen was pressing back, and sensors detected micro-vibrations that matched the pacing of living organisms. Video feeds captured fleeting shadows, long and sinuous, that did not correspond to any known deep-sea life form. The movements were precise, almost intelligent, and always avoided the camera when examined frame by frame. Scientists faced a growing realization. They were not just watching the abyss, they had entered into its domain. More alarming were the effects on equipment. High-resolution imaging systems failed mysteriously, their lenses coated with a thin, gelatinous film that could not be chemically removed. Temperature and pressure sensors occasionally ceased functioning, only to resume hours later, with recalibrated readings that made no sense. Mechanical failures did not follow predictable patterns. They appeared selective, affecting tools at critical moments when the trench's life forms were most active. Even micro-ROVs, designed for minimal impact, experienced inexplicable resistance and directional shifts. In several documented instances, researchers observed patterned tracks leading away from collapsed sediment areas, tracks far too organized to be random. The movement suggested behavior coordinated with environmental changes. an interaction between living entities and terrain engineered to conceal or reveal selectively. The trench was responding to human presence with precision, not hostility, but a form of awareness that challenged the very definition of ecosystem interaction. Chemical signatures further reinforced this sense of active engagement. After a lander deployed energy sensors, the trench's water chemistry shifted in ways that could only be interpreted as immediate feedback. Concentrations of reactive ions, previously stable for months, fluctuated in precise timing with the equipment's movements. These fluctuations indicated not just chemical processes, but a capacity for localized environmental manipulation by biological or hybrid mechanisms. Observation had triggered a response. The most vivid encounters came during high-speed excursions along canyon walls. A gelatinous form, tens of meters in length, appeared to follow the ROV, maintaining a distance while mirroring its movements in slow, deliberate arcs. Its body refracted the dim bioluminescent signals, creating patterns that resembled communication. The ROV's instruments picked up low-frequency pulses, synchronized with the organism's undulations. These pulses were not random. They aligned with previous acoustic signals detected across kilometers in Chapter 2, suggesting the trench harbored entities capable of coordinated, long-range interaction. Scientists began to consider that these encounters were not anomalies, but intrinsic behaviors. The abyss was a responsive system, a network of organisms, chemical processes, and geological activity operating in a way that challenged conventional notions of observation. Every approach, every measurement, was a conversation with an environment that did not tolerate passive study. It became evident that true understanding required a new kind of engagement, one that accepted unpredictability, impermanence, and interaction as fundamental principles. In the final months of the mission, teams recorded sequences where landers were nudged slightly, gently redirected by forces invisible to the human eye. Organisms were seen manipulating sediment to create patterns resembling territorial boundaries. Chemical gradients shifted immediately after landers passed. Even light introduced by cameras seemed to provoke movement and responses, indicating a level of environmental awareness that was profoundly unsettling. Researchers concluded that the trench was not merely alive. It was conscious in its responses, shaping its own observation. The deep ocean trench evolved into a living, responsive ecosystem that interacted with humans rather than being passively observed. Explorers realized that life, terrain, and chemical flows formed a complex system capable of adapting, observing, and concealing itself. In this abyss, humans were not just studying the environment, they were participants in its mysterious, interactive world. Were you shocked by the extraordinary discoveries scientists made in the crushing depths of the ocean, where life and energy behave in ways no one imagined? Share with us which moment of this underwater enigma left you most stunned.